Good morning to all the panels who are here, Dr. Cairo, Dr. Nurazwa, and Dr. Nazmin. Thank you for spending your time in watching and evaluating my presentation over here for my FYP. My name is Tiibban Ganthan, and my matrix number is B0517102213. As you can see from my slide, my supervisor is Dr. Saifudin, and I would like to thank him so much for making this project possible and easier by spending all of his time and effort in guiding me throughout this whole project. So the title of my project is UTeM's Lake Smart Water Quality Sampling using IoT application. Without further ado, let's get into my introduction. In the top left corner's diagram shows how much water the Earth has compared to the Earth's size. The biggest blob over there shows how much of all of Earth's water compared to Earth there is, and the smaller one beside it is all of Earth's fresh water. This visual representation shows how less of a resource that we have of water, and we have to be very careful with God's creation, and it's one of the main essential of life. Yes, mankind has been very irresponsible with water and all that ever since during the dawn of the industrial age. But right now, it's our turn to make a difference. So in order to make a difference, we got to test the water before even implementing any water improvement systems. In order to test the water, we have to go to the body of waters and do water samplings to check how much the water is polluted. And after that, we got to think of a way, of an efficient way to overcome the pollution or the dirtiness. On the right hand side, the diagram shows our two main body of water that we have in UTeM, the lakes of UTeM. There's Tasik A and Tasik B. Our lakes in UTeM are mainly used for recreational purposes such as kayaking and fishing. And if our body of water, which is our lake in UTeM, is polluted, there can be no recreational uses can be done, such as kayaking and all that. When the water is polluted, kayaking should be stopped. And same thing when if the water is polluted and the dissolved oxygen level of the water decreases, no fishes will live, therefore no ecosystem will be there, so therefore no fishing as well. After doing amples of research on journals and other research papers, there were several problem statements that I can come up with. And one of the main one is a lot of tools and time is needed in order to conduct water sampling. Water sampling is a very hefty job to do, where you have to go to the site itself, and sometimes you can carry a handheld device. In example, a HANA instrument, a dissolved oxygen instrument by HANA Instruments. And sometimes you got to take the water samples and go back to the lab, and you got to run some water tests from there to find out the pollution level or the dissolved oxygen level and stuff. The thing is that a lot of effort is needed in this, and to come up with a very efficient or very specific water quality index, you have to take water samples very frequently in order to get an efficient number or a more accurate number. All this is being done just to save and conserve the current ecosystem that we have, and this all have to be done in our ecosystem that we have in UTeM too. As for the objectives of this study, there are mainly two objectives that I have came up with. The first objective is to develop a water monitoring system at Tasik UTeM with the feature of Internet of Things. This is where I have to come up with a project, with a system where a dissolved oxygen sensor could be mounted to a computer board, in this case a Raspberry Pi, where I can connect directly to Internet of Things, and where I can monitor the value of dissolved oxygen level in our water, and including with biochemical oxygen demand of the water from anywhere with any device that can connect to the internet. This also allows for the data to be stored in the clouds. Secondly, reduce the time taken and the effort needed to test the water. This whole project is being done just to reduce and ease the process of collecting the water sample or the water data from the lake itself. After this, let's go to the scope. My main scope is dissolved oxygen. Dissolved oxygen level is very key in finding the pollution level of a body of water, and in this case, UTeM's lake. If the dissolved oxygen level is high, that means the water is clean and healthy. And if the dissolved oxygen level is low, that means that there's not much oxygen in the water for living things to respirate from, such as fishes and bacteria that break down dead materials. With the dissolved oxygen level, we also can find biochemical oxygen demand level too. When biochemical oxygen demand level is high, that means the water has too much living things in a small body of water. That means that there's not much air for or oxygen for the living things to have. Other than that, we have Internet of Things. Internet of Things is where physical objects with sensors and other technologies are connected directly to a monitoring device via the internet through a router, where it can be monitored from anywhere through any devices that is capable of connecting to the internet. And now let's move on to the related studies. From the research that I have done, this project stands out from the rest. Other projects involve stability sensors, pH sensors, but none of them includes a dissolved oxygen sensor, except for one system that have been commercially done by a company located in the United States of America. This device has multiple other sensors which directly connects to the IoT system, and this device is commercially produced to be used in the United States of America. Therefore, buying it over here from Malaysia, the conversion of the money will be very pricey, and since there are many other sensors on board, that means that it's going to be pricey too. It's not currently used in Malaysia. Much company and the government don't want to invest into this yet, just because of the price factor. Now moving forward to literature finding. There are several research papers and journals that I have read, and these are the three main ones that have been very helpful throughout this whole project. The first one is written by Nikhil Kadia on the year of 2015, and the key of the journal is about water quality monitoring for rural areas, a sensor cloud-based economical project. And from this journal, what I got from the journal is that water quality monitoring method sensors embedded design and information distribution procedures. And after that, the most important part, which is the sensor cloud domain. This helped me set up the cloud or get an idea of the cloud that I'm going to create for the project of mine. And other than that, improve water quality and awareness among people. After that, there's a journal by Tiibban and Jignesh Patolia, written in the year of 2016, and the key of the journal is real-time water quality monitoring system. This particular journal by itself was the most helpful out of all of them. First finding from this journal is that to ensure the supply of drinking water, the quality should be monitored in real time, where the quality of the water have to be always monitored at real time, not without stopping, so that you get a more accurate and more efficient water quality index or a water quality level. And after that, it is IoT based water quality monitoring system. It's exactly what I'm doing, but then my system involves a dissolved oxygen sensor. And after that, there's a journal by Socrates Katakis and fellow colleagues in the year 2016. And the key of the journal is Adaptive Edge Analytics for Distributed Network Control of Water Systems. And the main findings from this journal is that burst detection localization scheme that combines lightweight compression and anomaly detection with graph topology analytics for water distribution networks. And next we head on to the methodology. And this is the main conceptual diagram of my whole project, where it shows every single aspect, simplified version of every single aspects of the whole project. And in this case, the IoT system consists of Raspberry Pi system and a Wi-Fi module, which then combines with the dissolved oxygen sensor. This by itself is the main idea and the main project of this whole project. And it is then wirelessly connected to the cloud server using a router, and in this case I'm using ThinkSpeak. ThinkSpeak allows mobile users to download an app where they can access the data by themselves via internet anywhere at any time. And all the data that is received by ThinkSpeak is going to be a live data, and all the previous data will be then stored in the cloud. And in this methodology, we talk about design flow of the IoT device system and also the design flow of the Raspberry Pi system. In the design flow of the IoT device system, we start by determining the requirements of the system itself, and after that designing the flow of the system. After designing the flow of the system, we have to develop a code for the system where it allows the sensor to receive data and send the data to the Wi-Fi module, which then the Wi-Fi module sends to the router and then to the server itself. And then after that, after all the coding is done, we have to do some testing and refinement to find out whether there is any bugs to be debugged. And after that, we have to apply the system itself and test it in a real environment, and in this case is UTeM's Lake. And after that, the design flow of the Raspberry Pi device. The whole system starts by determining the requirements again, getting things ready, and loading everything on the SD card. SD card is required in the case of programming a Raspberry Pi system. And you have to boot up the Raspberry Pi using a other system or maybe a monitor or a laptop. After that, we have to run some programming for the Raspberry Pi system itself, and that's where it ends. In order to get the best results, the water sample is taken using a dissolved oxygen sensor meter by HANA instrument, which is a handheld device, at the same time as the finished system is used. This is where my project and the handheld device produced by HANA instruments is tested together in the same sample of water, and to check whether both systems produce the same data. And if both systems produce the same data, then the project is a success. And if it's not, then the project has to be fine-tuned, where we have to go back to the coding and stuff. Secondly, this is done to monitor and determine the accuracy of the device, accuracy of my device that I have created. I would say this is done also to check for any bugs that needed to be debugged. Now for the expected results of this project. And what do we expect is the sharp and accurate data of the water samples of itself. Other than that, time and effort taken to record and collect the data or the water sample data is decreased, where we find higher efficiency in collecting data of the water sample, in this case the dissolved oxygen level and the biochemical oxygen demand. Other than that, data could be viewed from anywhere and anytime live. This is so that the effort needed to monitor the data and to collect the data to decrease. And lastly, data is stored in a cloud for further analysis. This is so that in the future where any depletion of the dissolved oxygen level happens, we can actually spot the depletion early on from earlier existing data in our cloud. And after this, finally, we get into the conclusion. The implementation of the IoT to the water quality monitoring device would provide a faster and more efficient way for the monitoring and the inspection process of the water quality for our UTeM lake. Thank you for your time, panels. Thank you very much.